Before we start today's lesson, I'd like to just do a video answer key with you from yesterday's practice problems. If you haven't submitted that to the Google Classroom, pause and try them on your own first. Please submit them and then come back and check them. So if you need to pause this and go gather up your work from yesterday, go ahead and do that. And then we'll go over these. Okay, so number 7, remember this symbol here? There's just one single squiggle, means similar. And let me do a quick little mini review here. Similar means that the corresponding angles are congruent, but the corresponding sides are proportional. If they were congruent, the figures would just be congruent. Proportional meaning if you take the ratio between each pair of corresponding sides, that ratio is the same, exactly the same in every case. Okay, so number 7, they tell you these polygons are similar. The first thing you need to look for, you can see what I've circled here, are two figures, or sides, corresponding sides for which we already have their lengths. So we've got 4 and 8. That's what I used as my kind of ratio between all of the sides. If it helps, you can reduce that to 1/2. I thought that actually for this problem made it a little bit easier to work with. This is how I thought of this. The small figure to the large figure, small to large. Instead of 1/2 written this way, I wrote it 1 to 2 this way. So now in my mind, I'm just thinking, okay, this big one's twice as big. So instead of 3 here for TH, it's 6. Instead of 5, it's 10, etc. Going back to KN, of course, then you need to cut that in half. Number 8, we're trying to determine if they are similar or not. So you've got to check both pieces here. Are the angles congruent? And they are. You have 3 pairs of angles marked, but because all 4 of those angles would have to add to 360, that means that 4th pair also has to be congruent. And then are the sides proportional? So we're testing, and let me go through this first, and then let me kind of tell you the shortcut you could do here. In theory, you'd want to test all of the sides, right? 150 to 165. Is that ratio the same as 180 to 192? Is that the same as 140 to 154? But as soon as you find 2 that are not the same, or if you find 2 that are not the same, there's really no point in checking all the others. Now, kind of on the flip side of that, if you're going to say that they are similar, you would have to confirm that all 4 of those ratios are the same. Okay, but since some of them were not, I just stopped there. Number 9. Oh, I apologize for this watermark here. My free version of Smart Software ran out, so that's going to be here with us till the end of the year, I think. Okay, so number 9, they do tell you what are those? Hexagons are similar. Find our missing sides. So you can see what I've circled here. 88 to 66, that's a pair of corresponding sides whose lengths I had. I reduced that to 4/3. I thought that was a little bit easier. Now this one, just be careful because the one's rotated a little bit. So I actually had drawn on my notes just to sort of keep track. So SPIDER, so going from S to P, my eyes went around this way, right, counterclockwise, and then HNYCMB, so from H to N. So my eyes also kind of went around this way. So I'm matching up like 28 with this side, right? 56 with this eventually is 42. Okay, so that's my notes on that one. You can check all the answers there. Number 10, all the angles are good. All of the sides, notice I had to write out 1, 2, 3, 4, 5 different ratios here to confirm that they were all equal, but they are. So we would say all the sides are proportional. So yes, those polygons are similar. In number 11, I think it helps to redraw this one because it's sort of facing the opposite direction. It's hard to tell which sides are corresponding. And I use the letters here to help me do that. So ACE and IKS. So ACE, IKS, kind of thrown in the same spot there. Then it made it a lot easier to find these missing side lengths. So if you have X and Y switched, if you have those answers switched around, it's probably because you tried to match up X with 7 instead of X with 12. Okay. And then the last one here, oops, let's get this out of that watermark. Same thing, if it's helpful, I redrew, let's see, this smaller one. So again, feel free to do that. It might make the ratio a little bit easier to set up. Okay, so so let's start our next lesson here. 11.2, grab your notebooks if you need to. Make sure you take some notes with me. We are actually looking for triangle similarity shortcuts today. Maybe you can add that to the title of your notes here. If you remember, we had, in fact, let me just read this here. In the last lesson, we learned that in order for polygons to be similar, we must know two things. That all of the corresponding angles must be congruent and all of the corresponding sides must be proportional. Now, that meant we had to test like all possible pairs, right? Think about that one where you had to set up 6 different ratios. But triangles, similar to our congruence unit, are a little bit unique. There are actually some shortcuts here. So if you remember from the triangle congruence unit, we had side, 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 angle, side, angle, side, angle. This one could also be written this way, angle, angle, side. That let us basically saved us some work, right? So instead of testing that all 3 pairs of sides were congruent and all 3 pairs of angles were congruent, we found that if you just test a certain combination of them, that's enough to prove the triangles are congruent. There are similarity shortcuts as well, and I'm just going to list them here with you. Now, if we were in class, we would have, used patty paper or in our protractors, compasses, all of that, but let's just go through the list here. So the really big new one, and this is by far the most common one that we'll see, is just angle, angle. Here's what that means. If 2 pairs of angles are congruent, then the triangles are similar. Not congruent, similar. Okay, that is, again, by far the most common one we'll see, and really not a lot of work. So all you need to know is that if 2 pairs of angles are the same, the triangles are forced to be similar. Okay, so it's basically as if you had, let me draw one here. So let's say we take this triangle, I'm going to make a copy here and try to make a similar one. Now I'm not going to change the angles around. I'll show you that in a second. I can compare my angles. So look at these 2 top angles, congruent, congruent. These triangles are similar. Now, let's take this one step further. Of course, if the 2 angles are congruent, the 3rd pair also has to be congruent. So yes, angle, angle, angle is also a shortcut. And anything else that has 2 angles in it. So angle, side angle, side angle, angle. Those are all similarity shortcuts. Now, here's what does not work here. Let me make another copy. And you can see why the 2 angles are sufficient. So let me see if I can stretch this one. Oh, sorry, I'm having trouble here. Get back there. Oops. Sorry, guys. Okay, come here, little triangle. All right, just want to move this. Okay, so I'm going to try to skew it. Here we go. Okay, so we can see, now compare these angles up here. See that those don't match up. These don't match up. Of course, the 3rd pair doesn't match up. These 2 are not similar, or this last one is not similar, but these are. And again, really, all you need to test is angle, angle. Now, here's what it will look like in a diagram. You might just have this marked. 1 pair of congruent angles, 2 pairs of congruent angles. If you see that, that itself right there is enough information to say that yes, the triangles are similar. Other than that, basically all of the old shortcuts from congruence work as well. Okay, so let me make a long list here. So angle, angle works. That means so does angle, angle, angle. Just what we listed above here. Angle, side angle, 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 side. And then side, side, side. We're going to talk about that in a second, but this one works. So does side, angle, side. Okay. Just like congruence, if you have this one, side, side, angle, remember, read that one backwards. This one does not work because there are 2 totally different triangles that could be created. So I can't guarantee that they're similar either. Now, one thing I should mention about side, 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 it's a little bit different than the side, side, side we're used to. So this would say, write this out with me, if all 3 pairs of sides are proportional, then the triangles are similar. Okay, so we just need to check those three ratios, but it is a shortcut because you can ignore the angle measures. Okay, so it's just okay to test out that the sides are proportional. Okay, so let's look at some examples here. I'm going to do a couple here with you. If you have the link to the book and you want to pull up the actual page, that's fine. If not, I'll leave them on the screen when you're going to do a few on your own here. Let me 1 second here. Put that one up. Okay, so we're going to use the conjectures. We'll use centimeters for everything. Now, before we even try to find a missing measure, we first want to determine if the triangles are similar or not. Okay, so are the triangles similar? Now, here's what angle looks like. So notice tick mark number 1, tick mark number 2. So I'm just going to put a little note that, hey, I paid attention to this. I checked. There's angle. Yes, the triangles are similar. Now we can use the information there to find some missing side lengths. Okay, so this is just like yesterday's lesson. You're going to look for two sides whose lengths you already have. You've got a couple options here. I think these numbers are a little easier to work with. So 4 to 6 is equal to, and if I'm looking for G, look how I set this up. 4 is in the numerator, so G is in the numerator, G over 9. Okay, so 6G equals 36. I'm cross multiplying there. Divide both sides by 6. G is also equal to 6. Okay, so notice where that is, though. That's in the other triangle, so don't be alarmed. It doesn't have anything to do with that side. Okay, number 2, there's angle again. Nothing more to do as far as testing out if those are similar or not. Okay, and then let's see what we have here. 24 and 30 is a pair of corresponding sides whose lengths I already have. So I'm going to use that one. And then I'm missing two sides. H I'll find using H and 50. Okay, if you cross multiply and solve there, H ends up being 40. And then I'm going to still use the same ratio just because if I make a mistake finding H, it's also going to throw off K. I just have a better chance here at finding K correctly. So 24 to 30 equals 32 to K. And K ends up also actually being 40. Again, don't be thrown off by that. They're totally separate triangles, totally separate sets of corresponding sides. Now, number 3, if you look at the diagram here, so we have angle. We know the triangles are similar, but if you notice one's kind of rotated a little bit compared to the other, I think that makes it a little bit hard to look at. So I always suggest, and we did this sometimes with the congruent triangles as well, just redraw that. So I'm going to redraw another triangle that kind of looks just like this one, maybe a little bit smaller, right, since that one on the side is a little bit smaller. But I'm going to transfer over the tick mark. So now this one tick mark kind of lines up nicely. The 2 tick mark angle lines up nicely. And then very carefully we're going to transfer over our letters and all of the other labels. Okay, so R is where 1 tick mark was, K is where 2 tick marks was. That leaves A up here. And then fill in my sides as well. So AR is 24. So this one that was on the bottom ends up being kind of this left side. That makes it a little easier to match things up. AK is the one I'm looking for then. Okay. So now we have, let's see, so I'm just kind of ignoring this one that's over here. I now have 36 and 24 equals 42 over M. Okay, it's really easy to get the wrong proportion if you're looking at it this way because you might sort of mismatch the sides and get that proportion wrong to begin with. Let's see, M ends up being 28 on that one after you solve by cross multiplying. Okay, let me pull these problems up. I'd like you to try these on your own. Pull them up here so you can see them. Okay, now for number 5 and number 6, you're testing out, do we have one of those shortcuts or not? But remember, the S's in all of those shortcuts aren't that the sides are congruent, it's are the sides proportional. So I'll give you a little note here on number 5. You're basically trying to figure out, do we have side angle side? So the angle's good, are the sides proportional? Okay, so try those. Please come back to me in a couple minutes. When you're done, I'll finish off the video with the answers to these. Okay, so let's check our answers for the last group here. So I do have angle. Hopefully you paid attention to that. Only one of them was marked, but remember we've got vertical angles. We haven't seen those in a little while, so feel free to mark those congruent. This is another one. I found it helpful to redraw, just like we did in the previous problem. Once you do that, 45 and 30 is the ratio I used each time finding my other missing sides. Okay, if you have these wrong, I would really encourage you to redraw the triangles. You probably just mismatched which sides are actually corresponding. It's really easy to do that when they're shifted around. Oops, sorry about that. Okay, number 5. So here's what I mean by do we have side angle side. So the angle part, that's good. So the A that's in here, great, we've got it. The sides we're testing, are they proportional? So I want to know, does 37 over 30 equal 35 over 28? I would suggest just put those two fractions in the calculator. 37 divided by 30, 35 divided by 28. You'll see they're not the same number. The sides are not proportional. So the triangles are not similar. Okay, this is the issue, that the sides are not proportional. Okay, and then number 6 here, testing out the same thing, side angle side. This time, so we've got the angle, great, so the A is taken care of. Are the sides proportional? So does 104 over 91 equal 96 over 84? If you put those two in your calculator, yes, they are exactly the same. So yes, these triangles are similar. Okay, so the angles would be congruent, the sides would be proportional. Okay, that's all for today. Thanks for sticking with me.